textbook. I have explained you the concept of it. First, due to potential energy of a single charge. I have explained you the concept. Once again, I'll repeat. Once again, I will repeat only for you the potential energy due to single charge will be what? What we have to consider first. What will be the condition for this? Condition will be, yes, the condition will be your source charge. First thing, your source charge should be very, very, very greater than test charge. Okay, then what? Then we have how to find potential energy. For finding potential energy, we are using the formula. Which formula? Yes, we are using work done formula. What is work done? Work done is, yes, work done is only the potential energy. And what is the formula for, and what is the another formula for work done? Another formula for work done is charge into potential difference V. Another formula for work done is charge into potential difference V. And what is V? Yes, V is potential difference, and the formula for potential difference, we know it is KQ over R. If electric field is changing, we can write V is equal to what? We can write V is equal to integration of E dr. Okay, now let's see what's the theory given in this topic. So the first thing, potential energy of single charge. The specified charge whose potential energy is going to be determined. Let me highlight the point. The specific charge whose potential energy is going to be determined does not cause the external field. See that external charge is not responsible for producing that external charge is not responsible for producing external field. The source of external field is something else. What is the second point? Source other than the one specified charge are responsible for producing E. See what we checked, na? We checked in the diagram that there was a source. We checked in the diagram that there was a source. Sorry, let me change it. We checked that there is a source, and here we have external field. This Q charge is not responsible for producing this external field. It is produced by some other means. It will not be produced by neither by this charge nor by this charge. Okay, so source other than the one specified charge are responsible for producing E. Third point is the external source may be known, but they often remain unknown or unidentified. Clear? The external field or electrostatic field due to an external source is a known source. We assume that the source creating the external field are not greatly impacted by charge. The source which is creating externally, it will not be greatly impacted by the charge, small q. This is true if q is very tiny or unknown force are holding the external source in that place. Yes, I gave you the condition. The first condition was that only. What was the first condition? Yes, the first condition was that our test charge will be very smaller than external source. Then when extremely powerful source at infinity produce a finite field in the region of interest, even though Q is finite, its influence to the external source may still be neglected. So the external electric field E and associated external potential V might change from a single point to another. The amount of work done to move unit positive charge from infinity to point P is represented by what? It is represented by potential V. So the formula I gave you this in the introduction part only, that our work done is nothing but what? Our work done is stored in the form of what? Work done is stored in the form of potential energy. Okay, so I gave you this thing, but see, from this point it is clear that what we are using work done, and that work done will be stored in the form of what? It will be stored in the form of potential energy. Okay, now sorry. Then we have the next point as the amount of work required to move charge from infinity to point P in an external field is QVR, where VR represent the point's external potential. Sorry, this work is kept as Q's potential energy when a point P is in relation to origin with a position vector R, and it is written as QVR. The same potential energy, that same work done, that same potential difference, it is given by what? QVR. What I explain you sequentially, it is just given in the form of, it is given in the form of theoretical part. Okay, then what? Then we have, as a result, electron with charge q 1.6 into 10 raised to minus 19 coulomb is accelerated by potential difference delta V by 1 volt. It would gain energy q delta V, that is 1.6 into 10 raised to minus 19. This amount of energy known as 1 electron volt, and 1 electron volt is equal to what? It is equal to 1.6 into 10 raised to minus 19 joule. This is the very important unit conversion. You will need this in your dual nature chapter. 1 electrovolt is equal to what? It is equal to 1.6 into 10 raised to 19, sorry, 10 raised to minus 19 joule. Whenever you want to convert your charge from electrovolt to joule, you will use this conversion factor. Then now next next is our that same external field. Due to external field of a two charge or multiple charges in an external field, I explained you this thing, but I will just give you the theory part. What is there in our theory? Yes, this is of our external field. Yes. So what in the case of external field? What in the case of external field? Yes, in the case of external field, let us consider the example that you have a source charge. Then what you have after source charge? Yes, you have external field. I explained you the thing. I'm just recalling the concept. I'm just recalling the concept. This is our external field. E. In this, what we have in this, we have two charges, charge q1 and charge q2. Okay, from that external source, your charge q1 is at the distance of r1 and charge q2 is at the distance of, yes, r2. And the distance between q1 and q2, it was what? I'll change the color. It was r12. Now, if you want to find the potential energy of system, first, because of these two, there will be k q1 q2 over r12 plus what? q1 u1 plus q2 u2. Okay, why q1 u1 and why q2 u2? Because of, yes, because of this external field, this and this will be there. If there is a, if there was only one, we can take q1 v1, u1, sorry, so v1. Okay, and this is how we can find the potential energy of a system. Okay, let's dive into the next topic.